Welcome back to Sync My Music, guys. So I have brought back Max Hilsdorf to the channel. We had a great conversation about a month and a half ago. And Max is a data science consultant with Statworks from Germany. And the reason why I brought Max on originally is because I wanted to wrap my head around AI technology generally, but more specifically, the music generation models. There are many different apps and applications of AI coming online, but of course, we as music composers and producers in the TV film sync world, we're really got our eye on that music generative model stuff because that seems like it's the most threatening technology for our current source of income. So as we spoke in our last interview, Max definitely did point out that we probably shouldn't underwrite or underestimate this technology just because the current version of it is not that impressive and maybe not that human sounding. And sure enough, here we are, only a month and a half later, and Meta has just released something called MusicGen, which is their AI music model. Now, as I took a listen to it, I actually released a video on my channel. I'll link that below if you guys want to check that out, so to give you guys some examples of what it can do. I immediately heard a quality improvement, like a drastic quality improvement, not only in just the sample rate, but just also the music quality. It felt a lot more like a human being was behind the scenes there working some of the knobs, even though there wasn't. So I want to really bring a Max on today so we can talk about that model and why it got better so much faster and so much, probably a lot faster than any of us anticipated, and what this might mean for us as music creators and composers in the future. So Max, thank you so much for coming back, man. I really appreciate it. It's always good to see you. Let's go ahead and jump right into the Meta model. You were actually the one that kind of brought this a lot to my attention through a LinkedIn message you had sent me, a LinkedIn message. What caught your eye about the Meta music model? Why was it something that we really need to be paying attention to, especially those of us that are music producers and composers?
Yeah, I mean, in the first place, it isn't currently the case that like every day there's a new text to music model that's released. So it's always when there's a new large model, and when you know it's done by Meta or by Google, you know it's something big, right? It's not some research project. If they're releasing it, it's probably something at least semi-significant. In this case, it turns out to be pretty significant, I think. And yeah, so this is what caught my eye. I also have my people on LinkedIn who sent me the link. So like I discovered it just like you maybe from other people on the timeline, and I immediately checked out the demos because I think, hey, that's interesting. A few months have passed since we had MusicLM. There's been, of course, research efforts, but there hasn't been like a wide range of models released in the text to audio domain that were like competitive with MusicLM. But this one was really interesting because it's not only a new model by Meta, but it's also open source. And for me, of course, this is really important because what open source means is that you as a user can use the model, and if you know a little bit how to code, you can actually download everything. Like you can download the entire AI model and use it on your local computer, and you can do anything you want with that if it's non-commercial currently, but that's a licensing issue. So I think this is really significant. So if we have a model that's just as competent as MusicLM and is open source, that's a huge leap, I think, because what we want to use as musicians, obviously, is not just some lame text to music interface that I also saw in your video where you use MusicLM, for example. That's pretty cool, but like that's not integrated into your audio workstation. That isn't like the way you want to produce music. And I think with Meta's new model, MusicGen, we'll see these plugins coming up shortly and these add-ins and these audio workstation integrations of any kind. And I think this is just significant. And then on top of that, the model just produces much better sounding music. And I also have the same impression. Yeah. So it's really fascinating to see that something just after a few months is noticeably better in quality, and it's also open source. And I don't even know what's more significant. I think the open source part is even more cool. So yeah.
Totally. And a big game changer because, yeah, you're right. Anybody can now hack it, play with it, add, different, and figure out probably new applications that Meta had never foreseen. And that's what really a lot of those language models, essentially, ChatGPT and a lot of the open source ones that are out there, that's why a lot of this flurry of activity was really catching everybody's eye, because the progress was happening exponentially when you throw tens of thousands, maybe hundreds of thousands of brilliant minds into that sort of ecosystem. Who knows what the collaborative effort's going to be and some of the cool things that are come out with. So I agree with you that open source was a big deal. It was definitely one of the reasons why it should be something we're paying attention to, and why I'm kind of like, that's sort of the leader horse right now for me in terms of the music models of what we should keep an eye on. Talk about the sample rate. I definitely heard a sample rate improvement. I felt like I saw in one article that there was an improvement. Do you know definitively, was there an improvement in the sample rate?
Yes, I know there was an improvement in the sample rate and it's immediately noticeable, right? So, and I think the interesting part is if we just go back 1 year, so around 1 year back, maybe 10 months back, the best model out there was, I don't know, Refusion or some models that no one has ever heard about because they just didn't produce such nice sounding music. And a part of that was the sample rate. And MusicLM was already one of those models where I was surprised about the high sample rate they were able to do. I think it was 24K, which was impressive, but from a data science perspective, because I knew how the model sounded that we had just a few months before that. So that was already a sample rate increase. And now with a Meta's model, so I'm not sure if it's 40K or 32K or something along these lines, but it's definitely 32K or more. I would need to look that up as well, but it's not right at CD quality yet, but it's, I think, noticeable that there's a difference in sample rate. So everything just sounds cleaner and more, yeah, there's more fine-grained sound to this and more brilliant, I guess. So yeah, there was this increase.
And I want to follow up with that because I just read, and I believe this is probably the case, which is counterintuitive though. Google Music LM trained on about 300,000 hours of music content to be able to generate what it was able to do at that lower sample rate. And some of it was impressive, some of it not so impressive. So I'm thinking, looking at Meta's new model, I'm like, okay, they must have done 500,000 hours, a million hours. It must have been a lot more to get that higher quality. Shocker, they only trained on 20,000 hours of music. So that's kind of scary in a way because they actually used less content to generate a higher quality output. Can you talk about what potentially might have led to this higher quality output training on a much smaller data set?
Yes, I think that's really interesting because last time I also talked about that one of the classical, if you can call that classical, the ways in which we improved these large AI models in the last couple of years, the last 2 or 3 years, was pretty much just scaling them up. So you make the model larger and you make the data set larger in the same proportion. So you just scale everything up, more data, more model. So that's pretty much the formula. And this still holds true that if you take more data and you take a larger model and everything else, it's a good architecture, you know, it's well executed, then the quality is expected to improve. So you can do the scaling part. But recently, and we've also seen this in the language model, so the text generative model part, where I always say that music is a little bit behind. And I think we always see that we can anticipate the things happening in music when also looking at what's happening in text. And there we've had recent models which use much less data. It's not the models that are on like ChatGPT level, but these smaller open source models, they're now able to use much lower amounts of data and sometimes even a much smaller model to produce an output of the same quality. And in this case, we actually have a much smaller data set. And we also have not sure actually how large Music LM was, but the new model, it isn't an incredibly large model. So it's a large model, but it's not like huge. And it produces better output than the previous one that Google, for example, developed. And I think that's really fascinating. Part of this is just more efficient algorithms, more efficient model architecture. So that improvement that you can always expect in tech, right? If you have something today, it's going to be like 10%, 20%, 50%, 100% more efficient in a few months. You don't know how exactly it goes, but it's definitely getting more efficient. And part of it is just that, actually. And I also think, like, when you look at Music LM, they had a separate process. So they trained the audio generation process separately from the text to music understanding process. So those are two different processes with two different training data sets. So they had hundreds of thousands of hours of music, which they used for the generative part. And then they had a much smaller database, which they used for the text to music relationship understanding. And Meta pretty much was able, with a more efficient, it seems, and more effective also architecture, to merge both into one and train it all at the same time. And with some technical improvements and this new idea, kind of, it seems that this actually improves the output while having less data. So that's a win-win. Yeah.
Right. Now, I'm kind of curious as to why Meta put this open source. There's been a lot of stuff coming out of Meta lately. I've been following them, and they're doing a lot of open source stuff, which is kind of curious to me because traditionally Meta has, or Facebook has not been an open source type of company. They've kept everything under lock and key, and they don't show their algorithms and what's going on. So they've sort of pivoted a little bit in an interesting way. Usually I'm in favor of open source. I always find it a little bit more democratizing, obviously, and I feel like a lot of times technology can become safer that way because you just have more hands on it, more eyes on it, and less chance of somebody corrupt controlling it, right? If it's in the hands of the most amount of people. Why do you think that they maybe made this open source? And do you have any speculation as to what their plans are for releasing this model down the road?
Yeah, I think that this is interesting. I don't know the answer to that, of course. I can just speculate, just as everyone else does. I think there are two reasons that come to my mind. The first one being this wouldn't be a commercially successful model yet. So releasing this model there's not like a huge opportunity cost to keeping it secret, because if you kept it secret, well, then you have a secret model that doesn't earn you any money. So like, why do that? So like the incentive for keeping it closed is of course lower because these models are not just there yet where you can make like huge amounts of money with them. I think this will be a different incentive structure, I guess, when the model actually is really capable. And then you ask the question again, do we release it or do we turn this into a cash cow? So like that's the question there. And the other part is, I think we saw this with text as well just a few months ago. Again, I think it's 2 months ago, maybe 2.5 months ago. There was actually a paper or an internal paper leaked from a Google researcher. And it was an internal, like technical report, maybe you want to call it, that he wrote and sent to his colleagues at Google. And the statement behind the report was, we have no moat. So meaning like we have no unique selling point with our models. We don't have any competitive advantage by keeping our models closed and just giving it to people for money through an API or something and controlling all the infrastructure, because these open source models, they're catching up. Right, there's one person with a beefy laptop who can train a large language model now in an evening, whereas a few months ago, this was a full team of exceptionally well-trained data scientists doing the same thing over a few weeks. And so it's harder and harder for them to compete. And the conclusion that this Google paper kind of drew was that Google should position itself as a leader in the open source community to still be able to profit from these developments. And I think it's probably has something to do with that as well. So maybe this will change when the model is really ready to earn a lot of money. But I also think it makes sense for large corporations to kind of be part of open source. Don't try to keep everything secret, but try to establish a business model that includes open source and not excludes open source. I think that's what we're seeing. It's not commercially available, right? It's open source. You can't earn money from it. So that's one safety measure that they're doing. So I can use this to build BST plugins for free that I can like send to you for no money, but I can't do a business model around that. So it's already controlled open source, you know? Yeah, that's I think where it's going.
That makes a lot of sense. Yeah, because I've seen these large tech companies as they've got the cash to burn and they've got the R&D budgets to be able to pull off these kind of experimental projects, which is, you know, nobody else really can. So we're really fortunate and kind of, you know, in an interesting place, you know, as a society to have these companies. I always think of what is the company that's doing that kind of stuff? Well, I always think of like Meta essentially, because Meta is basically developing an entire VR universe now. It hasn't fully taken off yet. There hasn't a lot of sales. There's not a lot of attraction there, but they've got the cash to burn to essentially push this technology faster, quicker, better than it ever has. Now, Apple's obviously getting into it as well. So it's kind of interesting how these large companies are the ones that can kind of afford to push these experimental technologies forward. But then they sort of hit the limits really quick, and it's like, how do we sort of, you know, turn this into a profitable business? And maybe you're right. Maybe the open source is the only way in the short term to be able to do that. So we'll have to keep our eye on it to see where that goes. Now, I have a really technical question for you. We'll see if we can kind of figure this one out. So I'm also just really curious, how do these models, let's specifically focus probably just on Google's and Meta's, how do they specifically make this music, right? You know, I'm wondering, are they literally taking, let's say, a set of, let's say for Meta, they have 20,000 hours of music, and you type in, you know, I want a hip hop track. I'm guessing it's going through all the tags of text that say hip hop, getting all that music. So what is the specific, are you aware, what is the specific thing happening? Is it taking a track, just the audio, extracting, the waveform out of that audio and revamping it? Is there like a MIDI process where they're extracting the notes and using a MIDI programmer to? I would imagine that's not happening. I'm sure other models are doing that. Can you try to explain to us what's really going on with these models? How are they actually like technically creating this music?
Yes, definitely. I think that's fascinating. I'll try and make it as simple as possible because this is actually a really technical topic. So, but I think, so I think the first thing is if Meta's model is working correctly, it's not just revamping existing music. And I'll explain to you why that is in a second. But like the general process behind this is not to have a database of music tracks where they can draw some samples from and recombine them. But the goal behind these models, be it large language models or these text-to-music models, for example, it's to learn during this training process a generalizable knowledge. So it's something more abstract. What they are storing kind of in their model parameters, so in this big black box, they're not storing music snippets. They're not storing individual sounds or full tracks or something. It's no full track is kind of directly stored into this in this model black box. But what they're doing is they're developing abstractions of what music is. And I think there's a pretty high level way to describe this that's understandable. So first, you have to believe me that it's possible. If you have a text, for example, you give me any text, and you have to believe me that I'm able to turn this text that you give me into a mathematical representation. So we have to take that for granted. I can't do it with like 5 numbers. I can't explain any word with 5 numbers, but if I have 1,000 numbers, or maybe I have 10,000 numbers, at some point there's so much mathematical information that I can kind of represent the meaning of a word just with numbers. So it's possible. Let's just take that for granted. And I think if we know this, and we call this an embedding, I like to refer to it as kind of a representation of the music. It's a different way of conceptualizing a track, for example. And if we want to understand what these models actually do, I think we need to understand that what they're doing is pretty much that, right? So they're taking music and they're embedding the music, which means they take the audio and they transform it into this mathematical representation. And once you do that, you can compare the mathematical representations of different pieces of music and draw assumptions from that. Like, how similar are they? Well, I just look at the mathematical representations and I calculate how similar they are. That's pretty much what's going on in the background. So, and the key part is all the actual music, so what we consider as music, is abstracted out of the model. Inside the model, it's just mathematical representations, embeddings. And what they're doing is they're developing something that we call a shared embedding or a shared representation, because you don't have an audio input and you complete the audio or something like you have with ChatGPT, where you have text and the output is text, but you have a text input and what comes out is audio. And what these models are doing is pretty much they're doing the same thing. They're calculating these mathematical representations for the audio. They're also calculating mathematical representations for the text. And the magic with these shared embeddings is like they're transforming the music and the text into the same kind of mathematical representation. So once this happens, like you can compare 2 pieces of music by comparing their mathematical representations. And in the same way, you can compare a text and a piece of music by comparing their mathematical representations. So to sum this up, kind of inside the model, all is the same. So what it captures is meaning, and it captures meaning in a mathematical representation. And when we know that, we can understand what the model is actually doing, because what's happening is you throw in a text. The text is embedded, so it's put into this mathematical representation. And then what the model does is one sample after the other, if we want to keep it simple, 1 millisecond of music after the other, for example, it's generating the piece of music. And what it's trying to do is it's trying to generate a piece of music that has a similar mathematical representation to the text that was inputted. So it kind of goes all the way back. It doesn't compare a text and a music, but it generates music that looks very similar in this mathematical abstract representation. Is that helpful? Is that
very much so? So I do have one follow-up then. So
yes.
I get that, even though I don't understand the technical, like how do you actually turn music into math? But I do believe you that I think math is everything. Everything is math, right? So I get the model. It's basically putting together algorithms, equations, mathematical formulas to represent meaning in a particular piece of music. So you're saying they don't store, though, any of that audio, and they're not pulling from any of that audio format. So it's got an algorithm, it's got the text, and it's going to output now some audio. So my question is, where is that audio coming from? If it's not coming from what it's stored, it doesn't have MIDI tracks, I'm guessing. Like where, because something has to create a kick sound, something has to create a piano sound. Where is it getting these samples or these instruments to actually output music? Do you know that?
Yes. I mean, if you talk to ChatGPT, the thing can do two things. It can think and it can write letters. So if you take one of those away, if it can just think, you can't talk to it because it doesn't write words. If it can only write words, it can't answer questions because it can't think. It's the same thing with the music model. So the model has intelligence, and the intelligence is kind of how do I take a text prompt to something that sounds like the text prompt describes it. And then there's the knowledge part. So where ChatGPT, for example, takes knowledge from to answer your requests with something they know about the world, for example. These models have the knowledge about how to use this intelligence to turn a text into music. So what's stored in the model pretty much is, for one, the reasoning capabilities, how to go from a text to how the music should sound. And then they have pretty much the tools that they can use with the intelligence to generate the audio. So what's stored inside is, again, unfortunately, complex mathematical representations. We don't know what's going on, but what we know is the model pretty much is trained so that it can, when a text is inputted, it can use all of these numbers that it has inside in its internal configuration to take the text prompt, have an idea kind of what it wants to generate, and then draw all the tools it needs and all the knowledge it needs from its internal representation and start generating the music. It's tough to go deeper than that without getting too technical, but I would love to hear more follow-up questions if there are any.
Yeah, so because it sounds like when you say like it has the tools to be able to generate this audio, that's really where that's where the black box is in my head. I don't understand exactly, and maybe you don't, maybe because they haven't really released all those details, I'm guessing. But that's what's always been curious to me is like I sort of on a very general level understand how these models are working and doing what they're doing. But then it's always like, but something has to generate the music. And if they're constantly saying we're not using the music we trained on to generate the music, it's like, okay, so there must be some sort of a music generation tool in these boxes that, one part of the tool can create piano, one part can create, or is it so advanced that it's like basically turning, I mean, maybe that's something that I just can't fully understand, but I could get the concept of it where it's basically taking these algorithms, plugging it into some amazing new box of technology that can literally turn math into music, into actual audio. But it's so kind of foreign to how we generally think about creating audio that it just doesn't really, register in terms of what we think is possible. And maybe that's also part of the magic of these machines that we're kind of like, how the hell are they doing this? Yeah. It almost sounds like that's what they're doing is basically decoding. I mean, let me know if I'm totally off base here, that they're basically extracting, it's like the Matrix. They found the code inside of music, and they've been able to basically use a language out of that, create a new language, and feed it into this new technology that can spit out audio in a completely generative way that we've never been able to do. Is that sort of getting close to it?
No, I think that's absolutely right. So I would need to stress that those models are black box models. I don't know what's going on inside these models, like what they're actually storing, which information, and neither does Meta nor does Google. So we don't know. All we know is how these models are trained, what data is fed into them, and how they work. So we can kind of infer what the model probably learns on a more abstract level. That's why I'm saying it kind of knows stuff about how music can be produced, and then it knows how to understand the text input. And if you put both together, the intelligence and the knowledge, I guess, so the reasoning and the knowledge, you can start generating. And what you described, I think it's pretty much like that. So when you speak, for example, you don't actively think about every word that you speak. But if I asked you, like, why did you form the sentence that you just formed, like the last sentence, and how did you come up with that? You couldn't make that really like fully explicit. You could try and come up with an explanation, but it's like a post hoc explanation. It's like you do that after you do it. So you kind of try and reason why you did it, but it's not actually why you did it. The reason why you formed the sentence is completely hidden from you because it's happening so fast in your brain. So you could also ask the question, right? What's in your brain? There are no words in your brain. Like your brain is neurons and connections between the neurons. And every neuron has like some information, and the connections have information. And you can use this neural system that you have to kind of have a concept of how you can use words. And it's very similar to that. So just when you think about these models, think about how much you know about your own brain. That's how much we know about the models.
And that's the big part of this that I think is exciting, interesting, and scary, is the fact that even these companies developing these models call it the black box, because they don't even know really how this stuff is working. And so I think that's a good place for us to just put a pause on this part of the conversation. Max is going to come back for a part 2 on this one. You guys should definitely come back. I'm going to post it as my next video on my channel. We're going to talk about some of the, anger and some of the worry and fear out there about why are these data scientists and researchers doing this. They're just trying to screw over our lives, right? What is their deal? Why are they doing this? And I really want to talk about that, because we covered that a little bit in our last conversation, Max, but it's definitely just a topic and a comment that keeps coming back to me over and over again. So don't miss our next interview, guys. Max, thanks so much for your time today, and we'll come back with our next video basically in a couple days here, so you guys stay tuned.